Hi, this is Chris again. I'm here to talk about Unit 64, Problem 32 in the Mathematics for Machine Technology book by Smith and Peterson. I'm an instructor at Shoreline Community College. Let's analyze the problem. At first glance, it might look like this is a relatively easy problem. We can get a vertical distance from the difference of the vertical distances, and the horizontal distance from the two horizontal distances. But look carefully at that triangle in purple. Notice that the two lines defining angle x don't meet at the bottom to form a true triangle, because the radius can't be tangent to both lines at the same spot. So there's no easy way to measure angle x directly. So let's take a closer look. First, we know that a line drawn from the center of the circle to the tangent point of the vertical line will form a right angle. We can also draw a line from the center of the circle to the other line that forms x, and at its tangent point it will also form a right angle. Geometric Principle 5 states that the two angles are either equal or supplementary if their corresponding sides are perpendicular. So our new angle formed by these two lines is equal to x. Since there's no obvious way to measure that angle, we'll measure it by finding two other angles and subtracting them from 90 degrees. We'll start by drawing a center line, a vertical line rather, from the center of our arc to the top. Next, by drawing a line from the center of the arc to the far top of the white object, we can create two triangles. And by solving for angles A and B, we can calculate angle x. To do that, we're going to have to first find out what the hypotenuse of the two triangles is. The top of the triangle can be the opposite side of the angle can be calculated from the difference between the radius and 35 subtracted from the radius of the arc down below. So it's also going to be 50, just like the other segment on the opposite side happens to be 50 as well. And the difference between the heights gives us the 145 millimeter vertical distance on the other side. So that's our adjacent side. Now we can calculate the angle A using the tangent function by dividing the opposite by the adjacent, and we find that that gives us 0.344827586, and that's 19 degrees 0.025600604. Now let's calculate the hypotenuse. Now the hypotenuse squared is going to equal the two sides squared. So 50 squared plus 145 squared will be the square of the hypotenuse. 50 squared is 2500, and 145 squared is 21,025. Adding together we get 23,525, and taking the square root of both sides we get 153.3786165. That's our hypotenuse. Now we have the information we need to calculate angle B. Since we have the hypotenuse and the adjacent side, we'll use the cosine function. The cosine of angle B will be the adjacent over the hypotenuse. The adjacent again is our radius, 1. The hypotenuse is the one we calculated, 153.37, etc. And it gives us a cosine of 0.651991788, which is 49.308057 degrees. Now we have angles A and B. What's left is to subtract the two of them, add them together, and then subtract them from 90 degrees. to get angle x. So we add 19.02560,604 to 49.308057 to get 68.33366,304 degrees. Subtract that from 90 degrees, and we get 21.666,33696 degrees. Rounded to 2 decimal places, that's 21.67 degrees. And that's our answer. That's angle x. I hope you enjoyed this problem. Bye.